Good morning. Today I'll be discussing about deleting a node when item is specified. So consider the linked list with 5 elements. To delete a node when item is specified, for example, suppose 7 is to be deleted, then we're going to use two pointers, ptr and previous. Initially, ptr points to start and previous points to null. So here these two pointers are used to traverse the list. So each time the information part of the node pointed by the ptr is compared with the element that is to be deleted. Initially ptr points to the node with the element 4. Since it does not match, then ptr moves to the next node and the previous follows ptr. Now ptr points to 16. Again, 16 is compared with the element 7. Since it does not match, so ptr moves to next node and previous follows the ptr. Now ptr points to the node with the element 7. So here the match is found. So this node is to be deleted. So once you delete this particular node, then you have to create a link between these two, which means a node pointed by the previous and the node next to the one pointed by the ptr, using these statements. Previous points to link is equal to ptr points to link, which means once the match is found, then you are going to delete this particular item from the linked list. Then you have to create the link between the link of ptr and the node next to the one pointed by the ptr by using the statement previous points to link is equal to ptr points to link. Then the node pointed by the ptr is freed. So this is the concept of deleting a node when the item is specified. Here you are going to compare each and every elements of the node with the item. When the match is found, then you are going to delete that particular current pointer. Then the node pointed by the ptr is freed. So this is the linked list, resultant linked list after deleting the node 7. Next, algorithm to delete a node when item is specified. So first step, if the linked list is empty, then start is equal to null. Then it prints a message that linked list is empty. And go to step 9, end if. Step 9 is exit. So first step, we are checking the condition that linked list is empty. Next, step 2, if the item is found in the first node itself, then the first node should be deleted. So if start points to information is equal to item, then this node can be directly deleted, so that next start points to the second node. So once you delete the first node, then start points to the second node. Third step, when the element to be deleted is specified, we have to search for the information part of each node in the linked list to match the given item and then the element to be deleted. So for this, we're going to use two pointers, previous and ptr. Initially, ptr is equal to start and previous is equal to null. Next step, the list is traversed by moving ptr to point to the next node and previous pointer follows the ptr. Each time the information part of each node is compared with the element. So when a match is found, that particular node will be deleted, or the node to be deleted is found. So this is the statements for to traverse the list until the item is found or the end of list is reached, while ptr points to information is not equal to item and ptr is not equal to null. Do step 5 and step 4. Previous follows the ptr. ptr is equal to ptr points to link. Next step, when the item is not found, which means that if ptr is equal to null, to traverse the list until the end of the list is reached. So it prints item not found, exit. Once the node to be deleted is found, then make a connection between the previous pointer and the node next to that pointed by the ptr. Previous points to link is equal to PTR points to link. So just make a connection between link of PTR previous and the next node of PTR. First step is check whether the linked list is empty. Step 2, check if the item is found in the first position. Step 3, initialize pointers for traversal of list. Next step, traverse the list until item is found or the end of list is reached. Next step, if item not found. Next step is, once you delete that particular node from the linked list, then you have to create a link between previous and the next node of PTR. Step 9 is exit. Next, a C function to delete a node when the item is specified. So this is the function delete item int item. So initially PTR is equal to start and previous is equal to null. Here P is nothing but PTR. Check if the linked list is empty. If start is equal to null, then print linked list is empty, written. Next, check if the item is found in the first location. If start points to information is equal to item, then start is equal to start points to link. Which means that once you delete that first node, then start points to the next node. Free that current pointer and return. Here, traverse the list until you find the location or the end of the list is reached. Here previous, which follows the PTR, and P is equal to P points to link. Next, we are checking the condition that if PTR is equal to null, then it prints item not found. Else, so if the item is found, then you have to create a link between the previous link and the next node of PTR. Previous points to link is equal to PTR points to link.